Another complex numbers example, we have an electric motor. We're given this electric motor. It has a resistance of 10 ohms, an inductance of 0.025 henries. If the motor is connected to a source having a voltage V of 110 volts and a frequency of 60 hertz, and the current I measured in amps, where I is the voltage divided by Z, where Z denotes the total impedance of a motor. What we need to find is find I given that situation. Okay, so our setup, we've got an electric motor, resistance, inductance, frequency, the voltage. We remember from before that for an inductor that the impedance is J times omega L. Omega L is the angular frequency, which is 2 pi times the frequency. So Z is actually 2 pi times the frequency times L. So what we know is that Z total is going to equal, well, Z for the resistor plus Z for the inductor. So on this part it's just R. And on this part it's going to be J times 2 pi times our frequency times our inductance, which is 0.025. So Z total is 100 plus, get our calculator, 2 pi times 60 times 0.025. And it's that 9.42. We'll go ahead and put another one on there just to be safe. 9.425 J. And so that's helpful so that we've got Z total. And now we want to find I, which is V over Z. So V is 110 volts. And we want to divide that by 100 plus 9.425 J. And the problem here is it's really hard to divide in rectangular form. So what we need to do is convert to polar. So if we convert to polar, the magnitude of Z is the square root of 100 plus 9.425. Square both of those, take the square root. And the angle theta is the tan inverse of the imaginary part over the real part. So calculator, 100 squared plus 9.425 squared, take the square root. I'm sorry, I wrote down the wrong number for the resistance. The resistance is 10, 1.00. Fortunately, that hasn't caused us any real problems yet. Put the decimal point back in its spot. So what I actually get is 13.74. Ohms is the magnitude of Z. And to get an angle on it, we would do the inverse tangent of 9.425 divided by 10. And I'm doing it in degrees. And so what I get is 43.3 degrees. If I want to rewrite, so now if I rewrite this part of the equation, I know that I is equal to V. It doesn't have any imaginary part, so if we remember back, that really just means it's 110 volts at 0 degrees divided by 13.74 ohms at 43.3 degrees. And that still doesn't really make sense. So if we go one step further and change to exponential, we can see a little bit more why this makes sense. So that's 110 times e to the j at 0 degrees divided by 13.74 times e to the j at 43.3 degrees. Now it makes perfect sense how we do that division, because we've done division with exponents before. We can just divide the coefficients up front. 110 divided by 13.74 comes out to be 8.01. Almost perfectly 8. We just round it up. And then this is E0 minus the 43.3, so it's negative J 43.3 degrees would be our answer. Although we probably don't like to answer that way, so we would change back to polar and say that I is equal to 8.01 amps at negative 43.3 degrees. Well, that's technically correct. Generally, this is the way you report things. So the interesting part there is we have to go from rectangular to polar to exponential back to polar. Really a good way to kind of remember how to do all those different skills.